Now this illustration deals with when an overcurrent device can be sized greater than the ampacity of a conductor or the full load current rating of a motor. Now, many times where a problem occurs is when, say, you had a number 10 conductor feeding a motor or an air conditioner, and the overcurrent device is greater than 30 amps. Some inspectors, designers, and installers who really haven't had the time to be seasoned on this will go back to 240.4D, as in dog, and say, well, the overcurrent device for number 10 wire is limited to 30 amps. Now, that's a true statement. But when you look at 240.4G and table 240.4G, a motor is identified in that table 240.4G as a load where the overcurrent device can be sized greater than the ampacity of the conductors and motor. So we used to have a real big problem with this with home inspectors and different inspectors that were taught 240.4D for, say, 10, 12, 14, 16, and 18 size conductors. They were never taught, or whoever was teaching them forgot to do it or didn't know to teach them 240.4G. So we provided a table a few cycles back, table 240.4G, and listed loads in that table that would require an inrush current to start and run and operate properly. So now anyone that sees the overcurrent device size greater than the ampacity of the conductor or the motor supplied, whether designers, contractors, electricians, or inspectors, they can go to this table 240.4G and see if that particular load is listed there. If it is, then you size the overcurrent device greater. If not, then you're going to be you'd have to use the 125% rule. You're stuck with it. Now, so sizing the overcurrent device and the information, sizing CV to start and run the motor. The first section we would look at is 430.52C1 to round the device down, or use exception 1 and round the overcurrent device up, as we looked at. And then table 430.52 lists the percentages that we would use for a non-time delay fuse, a time delay fuse, an inverse circuit breaker, or an instantaneous trip type device. But table 240.4G allows this to be done, and table 240.6A selects the overcurrent device based upon a percentage that is selected from table 430.52. But this all begins in 430.6A1 that says and states you must use the table currents listed in 430 to get the full load current of the motor, not the nameplate. The nameplate is only used by 430.6A2, and that's when you're providing overload protection to the motor. Now, we know that table 430.7B, as in boy, would list lock rotor kVA per horsepower ratings, which we go through in great detail in our chapter in volume 2 that deals with motors. Now, I believe it's chapter 18. And it's a lengthy chapter, but it tells you everything you need to know about a motor. And you look up certain things that you want to look at, such as sizing the disconnect, the controller, providing overloads, sizing the conductors, the overcurrent device, etc. Equipment ground, all that kind of thing. Now, you notice in the illustration, we have an NEC loop. And we tell you, start with 430.6A. In 430.6A, it says if it's a three-phase motor, you have to use table 430.250. If it's a single-phase motor, you would use your table 430.248. Now notice 430.22 sizes the conductor. Table 430.52, as previously stated, gives you a percentage for selecting the type of device you want to use. Now we can use a circuit breaker in the service equipment, and we can have a non-fusible disconnect, or we could have fuses. But notice if it's a non-fusible disconnect, notice what you have inside there. Those fuses aren't fuses. They're just a solid connection that would be used to provide line and load connections. Now, the next thing that we would look at is the figure loop. If you wanted to go to chapter 18 and look at 18-1, 18-2, and 18-24A through 24D, as in dog, in volume 2 of the design book, those loops would show sizing the conductors and overcurrent device to a single motor, or 2 or more motors on a feeder, or 2 or more motors on a feeder with other loads. So that's in volume 2, gets into a little bit more detail procedures for sizing these items, these components. But now notice the motors are 50 horsepower, 3-phase, 208-volt, design B. Or it might be 50 horsepower, 3-phase, 480-volt, design B. The design letter, either B, C, or D, that is listed in table 430.251 A or B for single-phase or 3-phase motors, is the manufacturer's requirements for designing a motor, either design B, C, or D. Now, we also go through all of these design B, C, and D letters and what they represent based upon the driven load, how you would select a B or C or D. All that's in your chapter 18 in volume 2 of Stallcup's electrical design book, which gives you a lot more information. Now, you notice in the controller, we are using overload protection as a minimum 430.32A1. Now, I'd like to point out again, that's a minimum that you start with, but you could use a smaller if it would allow the motor to run and operate. That's just to get you started. And C1 would deal with that, and then 430.32, say A1, deals with the overload protection at a minimum, and 430.32C is when you can go maximum. Now, what that actually means, you would start with minimum and use increments up to the max of 430.32C to allow your motor to start. But any increment moving up on your overload relay will start your motor. That's where you stop. You just don't automatically put the max in. And then 430.35 is dealing when you just completely bypass the overload protection to allow the motor to start, run, and operate, and then naturally the overload is put back in when the motor is in its run position. Now, the disconnect, you can see in 430.102 locates it. It has to be located within 50 foot, basically, of the controller and the motor. That's the general rule. And then you have other requirements that you could look at where you'd locate that disconnect. And in our chapter 18, volume 2 of the design book, we illustrate this for you. 430.109A just basically says that that disconnect has to be 50 horsepower or larger. So usually that's a NEMA 3, which could be chosen from the tables that we have in the back inside cover of the design book. 430.110A basically deals when the disconnect breaks the running current and the lock rotor current. And this kind of gives you a good set of section numbers to review to understand just exactly why this section will allow you to size that overcurrent device greater than the ampacity of the conductors or the motor load served. So table 240.4G is the main table that we're using here. And in the next illustration, we will demonstrate sizing conductors and the overload current protection device in accordance with the NEC.